Hey everybody, welcome back. So today I'm working on an iPhone 11 that was sent here because it just suddenly stopped powering on. This is a logic board that I have determined that has a main short in a little bit of a unique area, and I want to show you how it is that I get to this area without disrupting the rest of the logic board sandwich. So when power is connected right here to the battery terminal, this board just immediately starts drawing tons and tons of current. And on this model, we don't really have a separate battery line and a separate main line. Here we've got the power that comes into the battery, and then right on the other side of R3303, we have VDD main. So R3303, this is going to be for current measuring between the battery line and the main power line. Essentially, we have the battery line and the main power rail just connected together through something that has very, very low resistance. This thing is measuring the current draw by just measuring the voltage drop across that resistor. So we really don't have to worry about a separate main power line and a separate battery power line. If we check this board for continuity to ground at the battery terminal, I'm going to use ohms mode here, and I've got my black probe on ground, red probe right on the battery line, and I am getting 0.5. So it's measuring a half an ohm to ground, and if I just take my two probes and touch them together, my meter reads 0.4. So this board has essentially a direct short to ground. Now, looking at this board with thermal imaging, we can see that it has a short up under the top shield here. So with determining that this short is most likely underneath this top shield, it is time to remove that. Now, the solder that is used to hold that top shield on, it melts way, way higher than the solder that is used to solder this whole entire logic board sandwich together. So here's how I'm going to deal with that. Now, I would very much like to be using larger Kapton tape for this, but I'm actually out of larger Kapton tape, and this is all I got left at the moment. So I'm just going to take and wrap this board tight. Yeah, so there we go. I've got the whole entire board wrapped tight with Kapton tape, and that's to hold this together as tight as it can stay, as tight as I can get it. So looking at the board view of this area, with thermal imaging, I have pretty well confirmed that our short is right here in this U5000 area. In fact, more specifically, I think it's going to wind up being C5000 or possibly C5004. In order to figure this out, the first step is to pull the shield off of this board and look at it. I'm going to cut right alongside of NAND. Now I'm not cutting out to the shield perfectly because we're going to need to be able to get to it with an iron. Same thing over here. I'm going to go just below all of these connectors. Trying very hard not to cut the actual connectors. Okay. Now, I don't typically wrap these boards up. I typically don't tape stuff off with Kapton. In this case, I'm not doing this to try to shield everything else from heat. I'm only doing this in a desperate attempt to hold this board together, because if this board floats and gets disrupted while I'm doing this, then I have to deal with a board sandwich issue, where otherwise right now it's just a problem with a shorted component on what I believe is just going to be the top board. All right, let's see if I've got this etched enough to peel off of here. Looking pretty good so far. Yeah. All right. I think we can pretty much stop right there. I'm going to flip this around and clean out alongside of NAND. I'm going to use 220 degrees C with an airflow of 65. I might turn that down a little bit because I don't want to be melting the solder between the board layers. And right now I'm just going after this goop that is right here between NAND and that shield. And this stuff at room temperature, it is hard as a rock. So we have to warm it up quite a bit to get it to melt. Once that stuff is hot enough, it should actually peel out of there in chunks. Now this is a number 11 surgical blade that I'm using. Thank you to the viewer that sent this in here for me to try out. So far it looks like it may in some ways be a little smaller than the number 11 X-Acto. All right, we're just about up to temp. It's starting to come out of there in bigger chunks. In most cases, I would warm this way up and then start picking at it, but I'm trying to do this as early as possible. There we go. Big chunks coming out. All right, so that's got all that garbage cleaned out of there. Now I can tell you by laying my hand on this board, we are nowhere close to having melted those perimeter balls yet. So we're gonna just get flux all the way around the perimeter of this goofy little shield. Now some people prefer to cut these. I prefer not to because I want to put it right back on like I found it. Cutting it may be less barbaric, but it looks like total garbage. All right. So this stuff, this low melt, I'll leave a link to it in the description below. It melts ridiculously low. Like if I touch that shield with it, it's probably already melting some. Yeah, look at it. It's already molten, and I can lay my hand on that board. This stuff melts at 138, which isn't even as hot as a cup of coffee. Like a good cup of coffee, I think, is coming out around 150, 160. So right here, I've still got my hot air set on 220. And I'm just going to take this stuff and try to get it to suck up and flow in here. We don't have to get along NAND because you'll see this stuff will travel all by itself. I'll just try to get it everywhere I can get to with the iron comfortably. Now, I would really rather not get this low melt all over components, so I'm probably just going to try to get it down, let's see, yeah, I don't want to get it across that row of components up there, so I am going to try to just get it down in here and probably stop right about there. All right, another big old glob here at the corner. Yeah, this stuff melts so low, it will surprise you. It comes apart very, very easy. All right, I'm gonna go ahead and turn my hot air up. And I'm gonna switch to a number 11 X-Acto blade because I don't wanna get this crap all over the surgical blade. I wanna save that for better things. Now I'm gonna start trying to get this thing to separate here at the corner, which we should see pretty quickly. And if it doesn't, I'm going to add more of this slop to it. There it goes. Waiting for it to cool. And then I'm going to try to get my blade under it, right there. All right. Now, you should be able to watch as this stuff spreads around the board as I peel it apart. It'll actually travel all the way around, and it's going to allow me to pull this off here with very, very little heat. And here in just a moment, we should be able to see where the short is. There we go. That's got our beloved shield removed. Now, while this board is still hot, or hot-ish, it's not really all that hot, I'm going to go ahead and start trying to wick some of this up, because this is not something that we want to leave on the board at all. And yeah, you can plainly see how even though I didn't get the iron between NAND and that shield, that stuff is just globbed all down in there, and it'll smear on your fingers. It's so cool. All right, so I'll just take some wick and start sucking some of this up. I can already see our cracked component. All right, now that I've got that shield removed and I've got the nasty alloy that I used to do so removed from the board, we can zoom right on in and have a gander at the suspect component here. It's going to be this gnarly looking cap right here that looks just completely awful. Compared to the one next to it, you can tell that it's had a little bit of heating. That's most likely my fault from sitting here cooking it with 6 amps, taking pictures for this video. And to get rid of that short, we're just going to take and pop it right on off the board. I'm going to insert my blade right next to it. It's going to be difficult not to damage the one beside it, so I'm going to get way down in here. And try to put all the force just on that one cap. We don't want to pop the one off next to it. We want to pop only that one off. In fact, it's in an easy enough spot to get to. Let's just use the iron instead of risking breaking something. Watch me try to take that cap off of there and then snap the IC next to it. It'd be something I would do while recording. All right, so let's just add a little bit of flux here. And to remove that, I'm going to use some 6337 leaded solder and my iron. The iron is going to give me the additional heat that I need, and the leaded solder is going to lower the temperature of the alloy. So we're just going to flood down in one side of it, which I can't really get to all that well, but I can get to this side of it. Keep heating it with an iron, and pop it off there with the iron. There we go. That was much, much more graceful. All right, let's get this area warmed up and clean that off. That'll work. And I'm just going to replace that with a smidgen of 6337 leaded solder. Okay, that's about a smidgen. All right, now I'm going to take us a brand spanking new capacitor. And put that right there on the board. It's just marvelous. So to put the shield back on, I'm going to be using the same alloy that we used for putting this board back together. It is not quite as low melting as what I used to remove the shield, but it is pretty low melting still. And this will work nicely to hold the shield in place. It won't fall off. And again, it will also travel around the board just like the other stuff did, so I don't have to get it absolutely everywhere. I would like to. All right, pick up some of the excess here I put all over this cap. There we go, that's going to be pretty good. Now, before I slop the shield back on here, I'm going to take up as much of this flux as I can. I will put a tiny bit of flux on the old shield itself and not so much on the board. All right, now it's time to get that shield back on there. This has a bunch of that gunk stuck on it, and here's what I'm going to do to deal with that. Just take some nice wick. Clean it off. It's a race against the clock. Can I wick it off before my finger burns? Ow! No, I can't. There we go. Shield as is prepared. And I will apply the flux directly to the shield around the outer perimeter. And stick it back on the board. I'm pretty sure that's going to go back on the board like that. Just like that. Okay, I see it melting along the side at the bottom. There it's melting along the top. All the way around the bottom. And I think I'm going to stop right there. I'm not really that concerned if this shield solders all the way around. I just want it to be soldered back on. And also I want it to be soldered in such a way that it's not laying up against any components. And for that reason, I'm going to move it a little bit. Very little bit, just right there. All right, hold it down and let it cool. Oh yeah, she's stuck. And because I like to be extra special, I'm going to run one little bead down here at the bottom. And then the same thing at the top. So that has that all put back together. Now, of course, I can't do much about the flux that's under that shield, but I am going to give this board a good cleaning outside once I make sure it works. Now, with all the tape removed, we can get a look at the edges of the board and have a look and see if I have floated anything or caused any harm. I am expecting quite a bit of flux to be oozing out all over the place, but what did not happen, and I'm very pleased to say, the logic board sandwich is still in one piece, and I am not going to have to deal with any sandwich issues. Let's go ahead and check and make sure that little short to ground is gone, and for that I'll check right at the battery terminal. So I've got the meter set in diode mode, and if we had a short, this would be close to 0.00. We are getting 0.30. That is a completely acceptable reading for VCC main. This board is going to be good to go, and this is going to be a happy customer. So there we go. I've got this board all cleaned up, and you can see that that shield is actually soldered back on there pretty nicely, and I'm reasonably confident that it's not going to be falling off of there anytime soon. And the last thing I will do to this board before reassembling everything into the housing is I will go ahead and put all of the stickers back on it. I've got it all reassembled into the housing, and oop, you know what? I almost forgot that battery connector. It's actually very important to make sure these pins are not recessed back up inside that connector like that is right there. This is from being worked on excessively and other people trying to get it working and whatnot. We're going to just want to give that little pin a push from the inside out and pull it out of that plastic like that. And then do the same thing right here on this other one. Just pull it out just a little bit. That is going to keep this thing from having battery data issues, which would cause this phone to reboot every 3 minutes. And all right, I'm gonna slap a screen on it, see if it works. So I've got a brand spanking new adhesive gasket installed. I've got everything reconnected, and I'm just about ready to give this thing a test run. And I have just noticed that this phone did not come with any retaining brackets, screws, pinlobe screws, or anything to put it back together. And it actually came in 2 pieces. I'm also staring at a note here that says, please send it back in 2 halves without reassembling. So that actually explains the missing pieces. All right, our output voltage is 4.8 volts. I'm going to connect a charger, 300 milliamps, 400 milliamps, Apple logo. And this phone is booting. We're now drawing 1 amp of charging current. I got a charge connect tone, and we are up to a lock screen with working touch. So this is going to be a happy customer. I'm actually going to be sending this phone back in 2 pieces so that he can finalize the reassembly. I'm not exactly sure why the other components were not included. Maybe this is somebody that just wants to see what I've done inside the phone before closing it up. That's completely reasonable, I guess. But anyways, if you like my videos, please give me a big thumbs up. It really helps me a lot to keep going. It helps YouTube to recommend my videos. And I will see you in the next one. Have a good day, everybody. Thanks for watching.